Welcome to this class. In this class, we are going to introduce the chapter deformation, and we'll start by introducing the concept of the tangent line problem. So the biggest question to ask ourselves is, what is a tangent line to a given curve? So that's the problem. So problem. What do we mean? Or what does it mean? To say that a line is tangent to a curve at a point so this is the question. When or what does it mean to say that a line is tangent to a curve, to a point? Now, if you consider this circle, this graph, this x, then this is y. If I have an arbitrary circle in this so this is a circle. Let's assume that this is the center of this circle. Now, if I have a point P here, then I can have, I call this point P. Now, through this point P, if I have a line so this line through point P can be described as a tangent. So with respect to this circle, this line that makes 90 degrees with the radius of the circle is called a tangent. So this is tangent. So with respect to this diagram of a circle, a line that makes 90 degrees with the radius of the circle and touching one point of the circle is called a tangent. So we can say the tangent line at a point P is the line that is perpendicular to the radial line, or simply the radius of the circle at point P. So that's how we can describe the tangent line at that point P on the circle. A line that is perpendicular to the radial line or the radius of the circle at point P. But then, let's see this other curve. This is just a circle is just a special curve. But this definition might not hold for a general curve. So for a general curve, however, the problem is more difficult. So consider figures below. Now, let me have this. Let me have this. Let me have this. Now, so let me call this one figure A, figure B, figure C. Figure A, let me have this kind of a curve, y equals to f of x. In B, let me have this kind of a curve, y equals to f of x. And in figure C, let me have this y equals to f of x. Now, let this be the point P. That's another point. So if I draw a line here, and then on this other one, I draw also a line there. And in this other diagram, I have this. This is still a tangent. This is still a tangent. This is still a tangent. But then the definition we gave for the case of tangent through point P on a circle will not work for all these three cases, because there is no radius where we are saying that the line makes 90 degrees with the radius line. So for this case A, we can describe so for A, we may say that a line is tangent to a curve at a point P if it touches but does not cross the curve at this point P. So that's how we can describe this one. A line that touches a curve at a point P, but does not cross the curve. That suits case A. But you see, that one doesn't work for B. And also, you see this line here, you can extend it. If you extend it, you'll see to be crossing this same curve at that point. So that definition doesn't hold for B and C. Now for case B, we may say, so this is for A, but not B. That definition can suit for the case of the curve in A, but not the curve in B, even C. And then for the case B, we can say a line is tangent to the curve if the line touches or intersects the curve at exactly 1 point. This definition works for circle but not for more general curve like in C. When you say a line is tangent to the curve, if it touches or intersects the curve at exactly 1 point, then that one leaves out this C, because you see, if this red line is touching this curve at point P, but if you are to extend it, then it will also be cutting at this point here. So there'll be 2 points. So that definition doesn't work for that line, though this line at P is tangent to this curve y equals to f of x. So then it means that these definitions that we have given can suit one specific kind of a graph or a curve and fails to suit for another curve. So we need to get now a formal way of describing a tangent line so that it holds for any given curve, like it holds for this case A, this case B, this case C, and also for the case of a circle. So let's give a formal definition of a tangent line. Before giving the formal definition of a tangent line, let's define what we mean by the slope of a curve. So definition. Let's define what we mean by slope of a curve. So the slope of a curve y equals to f of x at a point P, a comma f of a is the number m given by m equals to limit as h approaches 0 of f of x, f of a plus h minus f of a divided by h, provided that this limit exists. So that is the definition of a slope of a curve. The slope of a curve y equals to f of x at a point P whose coordinates are a, f of a is given by the number m, where m is a limit as h approaches 0 of the function f of a plus h minus f of a divided by h. Now, once we know how to define the slope of a curve at a point, then we'll be in a better position to explain or define the tangent of a curve at a given point. So definition, tangent to a curve. So tangent to a curve, or simply tangent line to a curve. So you say the tangent line, the tangent or the tangent line to a curve y equals to f of x is a line whose slope at the point. So the tangent line to a curve y equals to f of x at a point. At a point P, a comma f of a is a line whose slope at the point P, a comma f of a is m, which is given by limit as h approaches 0 of f a plus h minus f of a over h, provided that this limit exists and is given by y minus f of a equals to m into x minus a. So this is the equation of the tangent line to a curve at the point P of coordinates a comma f of a. So that's how we define the tangent to a curve. So because using words as we have seen in the explanation of these three curves and the circle, when you say that the tangent line is a line which touches a curve at only one point, then that contradicts this case C, yet this is also a tangent line. Also, that contradicts this one because this seems not just to be touching only at point P. So this is a general definition of a tangent line to a curve. So it's any line whose slope at point P is given by this limit, if it exists, and its equation is given by y minus f of a equals to m into x minus a. So in the next session, we'll be giving examples on how to find equations of tangent lines to some specific curves. Thank you.